Well, and another point of the function that you can notice here is that functions, they are actually make more flexible handling of the code, especially when you are actually repeating the code in more than one function. Maybe this is, I mean, like it might not be clear now for the time being, especially when we talk about like calling function only in the main function, as happens here. But let's say, for example, the simple example here is that whenever you're displaying a function, like you're writing a function and you want to execute this function more than once, right? So let's say like typing cout hello from function, let's say whatever like code you want to explain, you want to display. Okay, so it is actually more efficient to write, I mean, like the code in a different function, and then execute it as only one line of code instead of having it, I mean, like typing it over, like over multiple multiple line of codes. Let me just give you an example more than this. Maybe this example is it's very simple, that it actually runs a loop, I mean, like displaying a function within a loop. And actually, this is one ability of the function. It can be used within a loop. But what I'm saying, I mean, like what I meant by flexibility here is that it is that whenever you're like, let's say we are creating a function, calc to say, and that function is actually is attempting to that function is attempting to calculate int s equal to 6 and int y equal to 7, and as simple as int sum equal to s plus y, for example, and then return sum. Okay. All right. So here in the main, you can actually use it in a while loop, like int I equal to 0, for example, I is less than or equal 40 times, I mean, like 440, and then I plus plus. So here what you can do is that you can actually display, I mean, like execute that, so int calc, so we can actually cout cout calc. All right, so in order to separate the lines in here, you see, so meaning here is that actually I can execute calc here about like 40 times. It depends on how many times in a loop. Imagine that if you want to, I mean, like if you don't have that kind of function here, you will need to write all this code here and like in one piece, and this is actually very unmanageable to say. Maybe, I mean, like, okay, maybe the issue or like the situation here is not really so critical, but imagine that in another place, and we have seen, I mean, we have said that is that in void, if I said that in another function, let's say we have another function here, let me just even do it for you from now. However, we didn't take that point that it's there is actually a new point that we will study. It's called a hierarchical calling. All right, but the flexibility of the function will be explained here in the hierarchical calling. Hierarchical calling, it's just as simple as that, calling a function not in the main function but calling it in another function. All right. So again here, so let me just write like void any calc. All right, so that will have this, and int let's say int sum, no, let me just write like double rate equal to what, write a double rate equal to here calc. So of course this is possible, as I told you. So calc is divided by whatever number. I'm just writing any kind of equation, it doesn't matter, and it doesn't follow any like any kind of logic, you see. So cout, also I want to display what is rate here. Okay, so rate is, to make it more meaningful, and saying rate inline. You see, in this case, I'm actually calling a function. I mean, like this function. Actually, I have to move this function actually in the beginning, because you see, without it, here, it has to be here. Why? It is now okay. So I'm calling this function now calc. I'm calling it under AnyCalc, but AnyCalc it's not being called anymore. It's not being called in any place. So only calc is being called in both AnyCalc and main, but AnyCalc it's not being called at all. So this will actually cause that this function it will not be executed. So let's say that you want to also call the function AnyCalc. All right, let me just put it out of, all right, so let me just put it inside the code to indicate it more. Okay, AnyCalc. Remember, again, actually, I'm just typing any kind of logic. You don't need to think of the logic as much as the meaning of why I'm writing this. Okay, so I don't have like any specific logic to describe this, but the meaning that I'm trying to illustrate to you is that now I'm trying to show you the importance of having a functions. You see, because you see in that function I'm trying to execute this code in different places. See, so the first place I'm executing this code here in the main, and then I'm executing by calling the function name, and I'm calling this function again, see, to execute its code while it's being used in an operation. So this will indicate, you see, imagine that if you have, if you don't have function, you will need to write, instead of this, you will need to write 1, 2, 3, 4, 1, 2, 3 lines. All right, so you will need to write 3 lines in here, and also the same thing, 3 lines in here. So if I executed that kind of code, this is what will happen, of course, because I'm having a loop here. See, so that's the idea here. So it is very flexible. So writing a function here, it will be so flexible in order to be executed more and more again. All right, so the other point here is that, see, if you notice that whenever I'm executing, I want to compile that program, I have to make sure that the call of the function happen to be before, after its definition. So let me just delete this code to make it simple again. And also, all right, so this is it. So this is a function call here. So calc and AnyCalc. And in AnyCalc, I just want to say that I do not want to make it so complicated. I will just delete this to indicate that it's just that, it displays whatever value. All right. So and here it's only AnyCalc. Of course, calc here has to be, because it doesn't has any print out statement here, calc has to be in cout end line. Okay, all right, so with that, if I want, imagine that, of course, before this I have to place these functions in the beginning so that I'd be able to call them as we have mentioned before. But imagine if I'm actually using these functions in the backward, and I have called this function as the situation that I was explaining just now. For example, I'm calling this function inside that function. So even imagine if I just call this function in another function and another function. So this will make it very tedious and headache to keep ensuring that the function body is listed or is placed before the function call. Okay, or it's placed before the function calls. So that's why there is a solution out of that, is to use what we call a function prototype. And as you know from theory, function prototype, it is just a definition for the function that it's placed at the very beginning of the program. So where is the very beginning? Usually here, right after a student, right after using a namespace std. And remember this, so we are not now talking about main, so we need to forget about main. You see, main here happen to be in the end. So remember this, you don't need to write a function inside a main. So because you see, I have seen this unfortunately from some students. We cannot write like a function inside a function, because at the end, so this is a function and this is a function, so we cannot write both functions inside, and we cannot write whatever prototype that we're going to use now inside the main function. So the main function, it's just a function as same as other functions. All right, so here we're talking about like equality. in the same level. We are talking about like creating containers that are functions that does the same thing as the main function. The only thing difference here is that the main function has to exist, has to be there, because it's the core component of the program that the compiler will runs, that the compiler will look at. All right. So anyway, back to the prototype. So the prototype, it will enable us to execute. It will enable us to execute the body of the function no matter where the function is being placed. So imagine that the function is being placed here, as I have told you before. So of course this will bring an error, because you see the error here, this is not defined, and also this is undefined in the same thing. All right, it's because you see the definition here happened, the call here happened to be before the function definition. All right, so the function prototype here, it is just a way to identify the function. So how do we do that? Is that by copying exactly the same function header, all right, and put a semicolon at the end, and also copying the same function header here, going to the other one. Of course, every function in the program has to have a prototype, either a prototype or it has to be defined before it's being used. It has to have either a prototype or defined, or both. It's okay. So even if we now copy this, this kind of function, even if we copy it and paste it here after the main, before the main, with the prototype, it's also possible. It doesn't matter. But you see, why do we need to do that if we are actually doing prototype? This is the question now, you see. So prototype can do this for us. It can solve us the problem of the function location. So execute this, and yeah, see, I'm having this. It's because, all right, so int main here, calc, seems that I'm having an error. Yeah, all right, because this is, I forgot to delete the for loop closing bracket here. All right, so executing that again, and there you go. So everything is working fine as expected. All right, so with that, we can see the importance of the function prototype. Although the functions are being defined before the call, after the call, but still, because we have a prototype, this is the call of the function. Again, let me just hand this function call for both, actually. So both of these are function call, but the first statement happened to be calling a function. Here we are calling a function within a cout, and this is possible. Even we can call this function within a cout, but why do we need to do that for the second function if we have like a cout inside? So it seems like a cout inside a cout, but this is actually not kind of possible. All right, so remember, this is actually a function call. This is a prototype, and you see the difference here. The function call here, it is only the function name, but while the prototype, it has the function name and the return type, and this is the function header. It is typically as the function prototype, but without the semicolon. This is wrong. We cannot write it like this. This is the function header. Comment it out. And another point is that the only prototype that, the only function that doesn't have a prototype is the main function. It is because actually the function that the compiler by default will look at intentionally, all right? While other functions should be defined in order to tell the compiler that they are existed there. All right, so and this is actually the end of the theory. This is the end of the explanation, to say, regarding the the practical points in the lab. I hope that I have covered all the points that you may think of as in the in the practical part. Look at this question and just take it for you to answer that. You see here we're talking about the parameters. However, we didn't talk about we didn't handle them, or we didn't take them. Maybe in the next lab we'll be handling them. But finally, the question is asking you to, what is a proper prototype? Again, what we said is that this is the header. So in the prototype, we need to copy the whole thing and adding this. Of course, you need to copy it again here. All right. So we cannot just simply modify the code by just adding this. So this will be error. It's because this one now is acting here. It is just a part of the function. This is the function header. So in order to create a function prototype, it is to copy that code here and write it here again, and having the semicolon. Now you're typing, and you are creating a function header. Okay, so I will just leave it for you to attempt while just going into this example. This exercise is for you also to create, to attempt. I have many exercises even here, and I want you to take these exercises as your homework that you can actually train yourself. Even with that exercise. Okay, so let me just hand this out as also a homework for you. All right, so with that, I will just need to solve you one, maybe like one example that I will go through with you here. Let me just take this example because this example has an idea, and it has a very creative idea, a kind of a tricky idea to say. All right, so the question asks, create two functions actually, where one of them displays just this text, whatever text it is. Inc, what do you think? Inc, what do you think? And the other one returns the value of x equal to b. Call both functions from the main function. See? This is how, like the structure of the question will be look like. And you need to understand. So return a value, meaning that you need to look at what the value that is being returned. And you should be able to define then what is the data type of that variable, and then what is the return type of that variable, of that function. Sorry. All right, so let's just wipe this out, leaving the main function only, because this is the main, like this is the default this is the default way. And from now on, let me just advise you, please try to use prototypes as much as possible, because this will actually help you a lot later on to avoid any kind of errors, especially when you are defining a function after the main function and then calling them in the main function, or like defining a function and call it in a place before its definition. Okay, so all right, so coming back to the question, write two functions where the first one is displaying. So remember this, any function that is actually has a task to display, most of the time, in most cases, not in most, let me say that I'm just really advising you to write it as void. So void, let's say text, and open close. So use this, let me just write this hint for you. We use the void functions if its task is only to return, its task is only to display a text. That's it. If it only displays a text without doing anything, okay, fine, maybe like CNC out and final displaying, meaning that we are asking the user to display something at the end, that will be fine. We can use actually void. But if it is actually returning a value, and it has been asked here, and returns a value of x, of course we cannot do that with a void. So this is how we define which, what is the return type of the function here and here. So with this one, we define it as, we decide the return type here as to be void. All right, so in the void here, we can just write simply the required text, inc, what you think, and then even I will use that one /n because this is only text. All right, so again, whenever I created the function, the first thing, again, I'm telling you, maybe I didn't even go with you here, but I have just mentioned this in the theory. In the beginning, the first thing here, it's not to write the function call, although the main function may exist or may be written before the function that we are creating here. But the first step in order to create a function, it is to write the function header itself and its body. This is the very first step. And then after this, not the call even, after this is to write the prototype of the function. So the prototype, again here, it's void. Until now, it's void text, open and close brackets. So this is the function prototype for the first function. All right, so for the second function, and I really advise you first, even after you finish the prototype, don't go and actually call it. So just go with the question, and then follow the flow of the question and see at the end. If you notice here, I'm only asking you to call both functions. It is because I want you to follow a specific logic, which is the correct logic to to develop functions. First, we create a function and define them, whatever functions all together, we create them, and then at the end we just call them according to the place that has been asked to call them from. All right, so the second function here, it is because returning a function, it's a returning variable function. So it has to have, let me just see. So before I start anything, I will need to look at what kind of value it returns. It returns kind of a character value here. So that value, of course, has to be a char data type. So right away, I will just define a char. So char, the name could be any name, code, for example. It's just up to you, same as the variable name. So it's you are the one who are creating it. So it will be correct as long as you are not using keywords. Okay. So here, what I need to do is that I cannot write int here. It's because here I'm returning this variable. I'm returning the value of this variable. Again, so if this variable has that value, then what is the type of this variable? It should be actually char. Because typically it's by default there. The return type have to be same as the return of what, x. Then here I have to decide what is x here. So of course, because this x, like this return, the return type of the function happen to be for x, for sure x here cannot be any type, cannot be any data type, but only char. I cannot put it as int or as a string even, okay? Because this will be wrong. Then it will be what value it's being asked to be returned. So this is it. So now I have created the function and its body, and then I will need to call it as in the prototype. Like I will need to make a prototype for it, and this is how it does. So from the main function, I will just call both functions. So how to call them? So by just mentioning the first name, like the name of the function with the parameter list, which is empty, and then code here of the function, and that's it. All right. So call them from the main, since you see, that's why I'm telling you, even if the question doesn't ask you to print out, only call them from the main function. Maybe this one, maybe the first function here text, it's already printing out something using the cout command, but for the second one, it doesn't include any printing out. It only returns a value. So in order to make sure that we are returning, like we are correctly reading from the function here, it is much better to put that code, like that function that has a returnable type, it is much better to put it within a cout. Okay, unless it was asking, unless the question was asking, assign the value of the function that we have created here to another variable, to another local variable in the main value. So a local variable meaning that you are defining a char, for example, code, for example, 1, and then you are assigning it into code. So this is a local, kind of a local assignment, as I have explained to you just now. All right. So I will just use this in line, and that's it. So either way is possible. This is not asked in the question, so we do not need to consider it in order not to confuse you. All right. So this is it. So this is the question, and now I can execute it. So this is it. So ink, what do you think? And B. So very simple and sweet, and it's very easy. Even the first question is easier than the second one. So you can actually go for the third, and you see, you can actually find a lot of ideas here. And actually, I'm kind of challenging you, especially in this kind of question. I'm really challenging you in this kind of these problems, and those who are able to solve these kind of problems, they are really getting the full benefit out of this tutorial from, like in both theory and the practical. So with that, thank you for watching, and I will see you in the next lab where we'll be going to extend the, that function, the function tasks in order to send data and receive data as I was promising you. All right, so with that, thank you so much, and see you again.